Welcome back as we continue our wonderful lesson in additional mathematics. My name is Nanaya Wedu. You can call me Nana. Remember to subscribe to my YouTube channel so that you can be abreast with every video I put out there. In this lesson, we are continuing with binary operation. In our previous lesson, we considered a property of binary operation, which is the closure property. In this lesson where we are looking at number and algebra pattern, specifically binary operation, we are going to look at a very wonderful property, the commutative property of operation when it comes to binary operation. Now, let's consider the commutative property. Now, in the commutative property, all that we are saying is that if you have two elements of a set, so let's say A and B, which belongs to the set of real numbers R, and there is an operation A, operation B, we can also have it written in the other way around, B operation A, which gives us the same value, right? So we are saying that A operation B belongs to the set of real numbers, B operation A as well belongs to the set of real numbers, and A operation B is equal to B operation A. Now let's consider it in terms of real examples. So for instance, we can have A operation B to be equal to A plus B, right? So for instance, if I have 1 and 2, where 1 represents my A and 2 represents my B, I can have 1 operation 2, which is 1 plus 2, and I know that that gives us what? 3. And then I can also write it the other way around, where I'll write 2 operation 1, and that can be 2 plus 1, and that also gives us 3. Now we see that for both 1 operation 2, it's also equal to 2 operation 1. Then we say that this is commutative. So we say a binary operation, which is a triangle defined on the set R of real numbers, is said to be commutative if A operation B is equal to B operation A. It means that when we find it in the normal way and we turn it upside down and find it, we should be getting the same variable. Now let's consider commutative property when we are looking at it under the table. So in this case, we have examples of the sets 0, 1, and 2. And then as we said, the rule is multiplication. Right. So for instance, if I have 1 multiplied by 2 in the set, what does it give us? 1 multiplied by 2 gives us 2. So that gives us 2. Now let's turn it the other way around. If I have 2 multiplied by 1, what does that give us? So 2 multiplied by 1 gives us 2. Right? So it means that 1 multiplied by 2 is equal to 2 multiplied by 1. So therefore, we can conclude that based on this, the operation is commutative, but it should be same for all the other variables 0, 1, and 2. So let's try for another variable 0 and 1. So if you have 0 multiplied by 1, what does that give us? 0 multiplied by 1 gives us 0. And then if you have 1 multiplied by 0, what does that give us? It also gives us 0. So we can conclude in this case that 0 multiplied by 1 is equal to 1 multiplied by 0. So in this case, the question is asking, is the set commutative under the operation? So what is your guess, or what's the right answer? So we can conclude that indeed the set is commutative. Right, now let's look at another example. So in this example, we have variables A, B, C, and D, right? So let's try A operation B. So in the set A operation B gives us B. Now let's try B operation A, right? B operation A gives us B. So therefore we can say since A operation B is equal to B operation A, then the operation is commutative, but that should be for all, if all of them works. So we can try B operation C, right? And we know B operation C from the table here gives us D. And let's try C operation B. So C operation B as well gives us T. So since B operation C is equal to C operation B, we can say that the operation is commutative. So we can say the set is commutative and the operation star, right? So commutativity is just looking at both the first part with the second part and then changing it the other way around and looking at the second part with the first part and ensuring that with each of them we get the same variable. So in this lesson, we basically considered the commutative property, where we've seen that a commutative property is where you have, let's say, A and B, and A operation B gives us B operation A, where A and B all belongs to the set. In our next lesson, we will look at how we can solve some examples on the commutative property. See you in the next lesson.